All right, welcome to the YouTube channel, Learning About Math. Math is fun. Today what we're going to talk about in this video is variables in algebra. And so let's talk about that. When you started off in your math journey, what did that mean? It meant times, didn't it? So if you had 4x2, you knew that meant 4 multiplied by 2 equals 8. Well, now we're in algebra, and this can't be times anymore, because now it's going to stand for something that we don't know. It's a variable is what it's called, and it's because it varies what it means, what it stands for. Later on we're going to solve and we're going to figure out what x is, but for now we're just going, like for a long time it will just be unknown. So it's our variable. So we will see different variable expressions, like, I got my book way over here. I wish I had it a little bit closer, but so sorry about the leaning over thing. So like if you have in algebra a number sitting next to a letter with nothing between them, it actually means multiply. So this is a new way of showing multiplying. Another new way we're going to show multiplying is a dot. So if you see 2.4, that's 2 times 4. So a letter sitting next to a number or a dot in between two numbers. Also, another way that we're going to show multiplying now is parentheses. So if I have 3 parentheses 4, that means 3 times 4. So parentheses are going to be another way to show multiplying. The one way we're almost never going to show multiplying anymore is it being an x, because now x is x. X isn't multiplied. All good with that? See, I'm so used to feedback that I'm going to have to ask the camera constantly, are you good with that? And the camera is just like, yeah, that's great. I understand it great. No more x's for multiply. We got dots, letters sitting next to a number, or parentheses now. All right, next idea we're going to talk about, let's see. Divide, okay? So we really are starting with the basics, aren't we? So our first thing was multiply. Now we're going to talk about divide. This will still be used as our symbol for division. But the other way we're going to show division is this. If you have, let me change that. Whoop, whoop, whoop. It's more fun with sound effects. If you have this also means 12 divided by 3, the fraction bar. So we're going to use the fraction bar for division also. Now we will use this still. It's not like the multiplying x that we're getting rid of, but we're going to use the fraction bar also. Now, remember I told you in the introduction video, if you've seen it, that I'm going to tell you the main things. I'm also going to tell you where there have been pitfalls. Sorry, I have to drink water. I've been doing this for decades now, and I've seen where kids mess up on math. So I'm going to give you warnings about things that you don't want to do. Now this is one, the fraction bar. I want your fraction bars to always be flat. I don't want to see this, 12 divided by 3, the cross fraction bar. Now there's one exception to this. If you're doing units, I'll let you do that. Now I'll explain that in a second. But the reason why I don't want the sideways fraction bar, the slash, is because I write messy, and so do you guys. And where this is 12/3, in a minute it'll be 1213, because the student will forget that that was their slash that meant division. So absolutely no slashes, unless it's not numbers and it's letters. For example, one of the things we're going to be learning in this section is a formula, and we're going to talk about it in a second, but it's that speed equals distance over time. A unit of distance is like miles, and a unit of time is something like hours. If you want to write units like 4 miles per hour with a slash, I'll let you do that, because you won't turn it into a number. That slash won't suddenly become a 1. Okay, I'll almost ask you again, does that make sense? Yes, you look like you think it does make sense. All right, so the fraction bar means divide. We're going to draw it flat, not as a slash. Very good. All right, next idea. Hold on, I have to get my old lady reading glasses here. All right, so next symbol for math, we've done multiply, we've done divide. What do you think's next? You're right, addition. The plus symbol is what we will use for addition, and the minus symbol we will use for subtraction. All right, that's all pretty good. All right, so let's look at this. I'm going to get rid of the little math this way. Okay, so this is the first kind of problem you do, and I'm going to turn this way. This is the first kind of problem you do in algebra. They will give you something like this, 8y, and then they'll say evaluate the expression when y equals 2. So here's our expression, and here is y equals 2. Now, this is something that you need to know. Math is not hard. Are you shocked? It's true. Math isn't hard. What makes math hard is the words. It's the English of math that makes math hard because, you know, you hear evaluate the expression when y equals 2. Well, that sounds like gobbledygook, gobbledygook. And so we need to make sure we understand what the words mean so we can do the math. Because it's really pretty simple. What it means is that they want us to substitute in 2 for y and evaluate it. Now, a couple of things. Whenever you do an equation, I want you to write your equation over here and then write your knowns and unknowns over here. If you've watched the introduction video, you know my background is in science, and it's just a really good thing in physics and chemistry and those hard sciences to always list your knowns and unknowns, then think of your formula, then substitute it in. So I want you to get very organized with your problems. Now, some of you have a habit of doing math in your head, and up until this point you've been excellent at it, and you don't write anything down, you just do it in your head. You gotta quit. And I know you're thinking, no, I won't. This is why. Once you get into the harder maths, your teacher, that's the British thing, is to call it maths, so I kind of like it, so I do that too. So your teacher needs to be able to look at your work and see what you were thinking. If you just do it in your head, they don't know what you were thinking. If you do your work and it's very nice and organized, then your teacher can look at it, understand what you were thinking, and if you got it wrong, they can write on it what you did wrong so that you can correct it. Also, there are people in this world, I know this is going to shock you, I hope you're sitting down, but there are people in this world who cheat. So teachers need to see your work so they know you did it and you didn't do a little sneak peek off of your neighbor. Now, of course, if you're homeschooled, there's no neighbor to sneak peek off of. But one day you're going to college and there's going to be a neighbor and the teacher is not going to take the answer without showing the work. I knew a guy he went to West Georgia, and he had taken a class where he figured out how to do some math in his head. He did it all in his head, and he wrote down all of his answers, and it was 100, a perfect test. And the teacher gave him a 50. They counted off an F plus, but still an F. Counted off half on every single one of them because he didn't show his work. You do not want that to happen to you. So I'm going to help show you how science and math teachers want you to show your work so that it looks good. Okay, so first we write down our formula. Second, we write our knowns or unknowns, and that will make more sense as we go on into algebra. Now third, this is a very important step, is we sing a song. Okay, the song is Substitute by The Who. It's from before my time, and it goes like this. Oh, and I can't sing. It adds to the comedic effect though. So it goes like this. Substitute. So you sing the song. Now, can you do the math without singing the song? Technically, yes. But if you're not singing and dancing, you're not having as much fun as you can. And these little songs and dances, yes, there's dances, and hand claps that I'm going to teach you is going to help put the main things in your head so that you know how to do it. Now, when you're taking the SAT or the ACT, just sing in your heart, because if you sing out loud, they might kick you out. So step 1, write your formula. Step 2, write your knowns and unknowns. Step 3, we're going to sing substitute. And that means we're going to substitute in our known into the equation. So we rewrite the equation again. Now if I just write it right underneath, what does that look like? It looks like 82. So we can't just write two numbers next to each other and understand. Remember, a number sitting next to a letter means multiply. So I'm going to put parentheses, because remember, parentheses also means multiply. I could have put a dot. So now we do 8 times 2 equals 16. Now, you could have already done this 10 minutes ago. But what we're doing now is we are learning these formats, so later on when we have the crazy big problem that takes a whole piece of notebook paper to do, we will be so good at organizing our problems that that we are not going to miss things because of disorganization. If you miss an algebra problem, I want it to be because you didn't know it. Not because you wrote messy or you were disorganized or anything like that. So this is like training wheels on our bicycle. We got to start with the training wheels, but then we're going to get faster and faster. And we're just going to be rocketing along before you know it. Okay, so that was our first example problem. Here's another one. Y is going to be equal to 2 for all of these. Okay, our next one is 10 over y. Now, do you remember what I told you that the fraction bar stands for? Divide. That's right. Okay, so we've written our formula, we've written our known and unknown. What's step 3? That's right, we sing substitute, because we're going to substitute 2 for y. So now 10 divided by 2 equals 5. Now, normally when I teach, I have kids. Alright, and the next thing we're going to do, I have to rewrite this, I erased. So y equals 2, and the next one they have us is, our next sample problem is y plus 3. So we've written our formula, we have our knowns and unknowns. What do? Sing substitute, and we write it right underneath. 2 plus 3 equals 5. Put a box around it. Ta-da! Alright, let's do another one. See? Algebra is not hard. This is going to be fun and easy, right? Okay, let's do another one. 14 minus y equals 2. If you hear a cat in the background, that's Ruby wanting to play fetch. That's her hollering for fetch. We can't play right now, though. Alright, so now we substitute, sing our song, and now we put it in. 14 minus 2 is 12. Put a box around our final answer. Alright, let's do some more problems. This isn't so bad. Okay, let's try our next one. Okay. Our problem says, average speed is given by the formula, speed equals distance over time. Find the average speed in miles per hour of a car that travels 180 miles from Boise, Idaho to the Minidoka National Wildlife Refuge in 3 hours. Okay, now this shows what I mean by knowns and unknowns. We know that the distance is 180 miles. We know our time is 3 hours, and we want speed. So we have a formula, we have knowns and unknowns, we can sing substitute and fill it in. So speed equals 180 miles divided by 3 hours. So 180 divided by 3, we can do this on your calculator, or you could just do it if you know your 3 tables. Then let me double check something here. Yes, I want to show you this. So 180 divided by 3 is 60. Now, remember when I said I wanted flat fraction bars unless it's units? This is what I was talking about. You can do miles per hour as a slash. Put a box around it. Now, let me tell you a little story about this. Okay, first of all, why do I do the little singing and all that? It's because these are hooks that's going to help put it in your long-term memory. It's not just because I'm crazy. Yes, I might be crazy, but that's not the only reason why I do it. So the more you will sing the little songs and play along and listen to my crazy stories, all of that is using hooks to get this information in your long-term memory so you don't forget it as soon as you're out of this class, like those public school kids that I used to teach who forgot their algebra and then they didn't have it when they needed it for chemistry and physics. All right, so here's the other thing. When I very first started teaching public school, education was not my first choice of career. I was going to be a pure chemistry major, and then I changed and I was going to work in a hospital lab. Well, once I started working in a lab, I didn't like it. It was too quiet. There was nobody to talk to. I used to talk to my test tubes, and I would call up my patient's name. All right, Mr. Smith, let's see how you're doing today. And I'd put the test tube in the centrifuge and turn it on and pull it out, and the test tube would go, oh no, Mr. Smith, you're doing terrible. So I was going crazy talking to the test tubes. So then I thought, I need something with more interaction. So I was working in physical therapy at the time, and I thought, that's it, I'll be a physical therapist. So then I was in grad school for physical therapy at Georgia State. I was working in it, and I really didn't like it. I found out that I'm not good at medicine, that if you do medicine, you have to hurt people. Nurses give shots, doctors do operations, and physical therapists make you do exercises till you cry. Like, you have a hurt muscle or whatever. And I started having nightmares that the machines were falling on my patients and killing them. And I had a very good patient who did die unrelated to physical therapy, but I just really started hating physical therapy. And I thought, I just can't take it. Every time I'd have to hurt somebody, doing a procedure to them, my stomach would just get knots, and my head knew that you have to go through some pain to get better, but my stomach just could not take it. So I decided to become a teacher, and there had been a movie that was out at that time called Dead Poets Society. And then it was an English teacher who just greatly inspired these students, and I thought I could do that, but with science and math. So I started teaching in the middle of the school year, and I had this one group of kids that they just seemed really rough and really scary. But I was all enthusiastic and happy, and so we had this formula, and it was in science. And I said, speed is distance over time. But it had been rearranged, the formula was had solved for distance, so it was distance equals speed times time. And I was like, okay, how can we remember this? Please excuse my dear Aunt Sally, is there some way we can think of something where we could remember this formula? And I had this kid in the front row look at me just deadpan, and he said, dead science teacher. I was just like, no, they want to kill me. Turns out, so anyway, I always remember dead science teacher, and that's why I thought this is going to be harder than that movie made it look. But it turns out that was a group of kids that had been classified as the most at-risk kids in the school. These are kids who have been to juvenile detention, kid jail, and all this kind of stuff. And they had been put together in a special group so that they could get special help. Well, someone should have told the science teacher, because I just thought, what is up with this class, and why do they hate me? But then one day they all had on red shirts, and I'm like, I didn't get the memo. Why? What about the red shirts? And they said, oh, we're in a special group. We're the most at-risk students. And I thought, someone should have told me. But I really grew to care for those kids a lot. And I kind of kept my eye on them because I was pulling for them. I was rooting for them. I wanted them to do well. But one of them, of the class of 30, one student graduated. Everybody else dropped out of school. So it was kind of sad because putting them all together in that group did not work. It didn't help them overcome where they would reach the goal of being high school graduates. So kind of interesting. All right, so that's our formula. We write our knowns and unknowns. We substitute it into the formula. And also what we are doing to the numbers, we also are doing to the units. This is miles divided by hours, or miles per hour. And a lot of times you can know that you're using the right formula if your units make sense. If it's a unit for speed and you get miles per hour, you probably did it right. If you get hours squared, times kilometers, then that isn't a normal unit for speed. You probably did the problem wrong. So that's called dimensional analysis, and it's a way of knowing that you're using the right formula. All right, let's see. Okay, here's another formula. Now you will use the speed equals distance over time formula in your homework. Okay, so here's another one that you probably learned in pre-algebra. It's the formula for perimeter. And to get the perimeter of a geometric figure, like a triangle, is you add up all the sides. The perimeter equals side 1 plus side 2 plus side 3. Okay, so we have this thing, and this side is 8, this side is 15, and this side is 17. So these are our knowns, and our unknown is perimeter. And it's okay. You don't have to have them just in a list. You can draw a figure, especially when things are geometric, and label it, and that's a great way of putting down your knowns and unknowns. We have our formula, and now we're going to sing substitute, and in we go. So 8 plus 17 plus 15 is going to be our perimeter. Did they give us any units? Nope. So if you add it all up, if you need to, you can use your calculator. The perimeter is 40. Ta-da! No units on that, I don't think. I don't see any. All right. Here is another formula. Here's your third one. You'll also use this one in your homework. And it is the formula for interest equals the principal times the rate times the time. It looks like it says PERT, like the shampoo, PERT. Interest equals PERT. And later on, there are other formulas for interest. This is the simple interest formula. So we're given that you deposit $6.50 in. So that's your principal. It's the amount you start with is called your principal. Into the bank at a rate of 8% per year. How much simple interest will you earn after 1/2 year? So our time equals 1/2. So we are going to substitute these in, 650, and I'm going to put these in parentheses, times the rate. Now, if you have a percent, whenever you do math to it, you have to change it to a decimal first. And this is something you should have learned in pre-algebra, but you might not have. And what you do is you move the decimal point, like there's an understood decimal there, you move it 2 places that way. And how I remember that is that this has 2 zeros on the percent symbol, so that reminds me to move it 2 places over. This place, it doesn't have anything there, so I have to put a 0. It's called augmenting zeros. Just put 1 there, because I had to move it 2 places, and you don't leave a blank there. You put a 0, just so I'll hold the place. And then times the time, which is 1/2 of a year. Multiply all of those together, and you should get that you would end up with $26. Ta-da! All right. So one of the big banes of existence in algebra is word problems. And what makes it hard? That's right, it's the words, it's not the math. So our goal is to get rid of all the words and just have the math. So I'm going to read a word problem and show you how I do that. Alright, we had a second of technical difficulty. I'm learning how to use my new camera, and for some reason it keeps cutting off. It's decided it's bored with this math problem and it's going to cut it off. So we're going to start this again. We're hiking, and the problem says we're going to get rid of the words. That's what makes a math problem hard. We're hiking at Jedediah Smith Redwoods State Park in California, and we're going to hike at a rate, so my speed is 2 miles per hour. And really, we don't care about any of those words. We just got to get rid of them and boil our problem down to knowns and unknowns and a formula. And then it's not a word problem anymore, it's a regular problem and it's easy. See? That's good. All right, so the first thing we were told, we're going to go a speed of 2 miles per hour. And then it says we want to know how long it will take, so that's our time. And I put it down, so that's what I mean by knowns and unknowns. And we are also told that we're going to go the Boy Scout Trail. And according to the map here, it tells us that that distance is 7.4 miles. All right? Now, the next thing we do is we think, what is a formula that relates these things? And it's speed equals distance over time. Now, what do? We sing substitute, and we substitute in right underneath the letters that go with them. So S is 2, D is 7.4, and for T, since it's unknown, I'm going to put an X. Now you can put T, but I'll just tell you the truth, I'm quite a bit dyslexic. Last take I said a little bit dyslexic, but as I'm getting older I realize I'm more dyslexic than I thought I was. And when I do different letters other than X, they can get turned around and flipped upside down. But do you know X's are the same if you turn them upside down or flip them left to right? There they are. So I like to use an X for my unknown. Now, what I'm going to show, so we got rid of all those words and now we just have a problem. Yay! Now, the other thing is, what I'm about to show you, you are not responsible for yet. It's where we're going, but you're not there yet. And it's how to solve for X. That is very important, and I'm just going to give you a preview. So don't freak out. It's going to be okay. But I'm going to show you how to solve for X. And this is how you do it. You do the opposite until X is by itself. Now, what does that mean? The reason why X is not by itself is it's being divided into 7.4. So what's the opposite of dividing into 7.4, dividing by X? It's multiplying by X. And I'm allowed to do that because I'm allowed to do anything I want in math as long as I do it to both sides of the problem where there's an equals. So I have to multiply an X over here too. So I'm allowed to do it because I did it to both sides. Now, I have an X in the numerator and one in the denominator, and you might remember this from pre-algebra, but I'm allowed to cross them out. If you have the same thing in the numerator and the denominator, they mark out. Now I'm going to bring down everything I didn't mess with. I've got a 2 and an X over here, and by etiquette, you write numbers before letters. Isn't that a little surprising? There's etiquette in math, but there is. And then I bring down my 7.4. Now, my question I ask myself is, why is X not alone? And the reason why it's not alone is it's being multiplied by 2. So I do the opposite. The opposite of multiplying by 2 is dividing by 2. And what I do to one side, I do to the other. How I write dividing is the fraction bar. Because I have a 2 in the numerator and the denominator, they cross out. And so now my answer is going to be 7.4 divided by 2 is going to be my time. And it is 3.7. I didn't have to use my calculator or my brain. 3.7, and my time, my unit is hours. It's going to take me 3.7 hours to do that hike. That sounds fun. I like hiking. It's one of my favorite things to do. All right. So that's it for variables in algebra. I'll come back and make the next section video that you'll be watching this week, but it won't take so long. I had to give you a lot of background stuff in this one, and these videos should get faster and faster, where they should end up being less than 10 minutes each, hopefully. All right, see you guys later. Math is fun.